So FRQ1 is a projectile motion problem, and it gives us the following information. The object is on a cliff that is at a height above the ground at 35 meters above the ground. And then the object is given an initial velocity of 50 meters per second, which is angled at 37 degrees above the horizontal. And then also air resistance is negligible, so we don't have to worry about that. And we're given that gravity, force of gravity is going to be, acceleration is going to be 10 meters per second squared, that's gravity. And it also tells us that sine of 37 is 0.60 and cosine of 37 is 0.80, which will help us with calculating the velocities in the different planes. So part A tells us to calculate the total time that until the project hits the ground at point C. So to do this, we'll use this formula. Displacement equals 1/2 at squared plus VIT. So we know that displacement is from the cliff to the ground here was given as 35 meters, so that's going to be written as -35 equals 1/2. We also know the acceleration is only due to the force of gravity, which is given at 10, and since that's also in a downward direction, we'll do -10 t squared plus VI. So this is going to be in the, I actually forgot to say that, since we're looking only at the acceleration and the movement in the vertical, we're going to denote everything as y. So displacement y, acceleration y, and then v initial y. So it's still the same because the displacement in the y direction is again 35 meters. The displacement or the acceleration in the y direction is again only due to gravity. And VIY we know to be v initial sine of the angle, which is 37, and we already have all the numbers here given to us. So v initial is 50 and sine of 37 is 0.6. And if you plug that into the calculator, that'll be 30. VIY is going to be 30 meters per second. So that is the initial velocity of the object in the y direction or the vertical direction. And then again t. So we can use a quadratic to solve this. We'll just put everything in place. So 1/2 times -10 is -5 t squared plus 30t, and we're going to move the -35 to this side. So that's going to be a positive 35. And we plug that into a quadratic solver, and we'll get that t equals 7 seconds. So t equals 7 seconds. It takes 7 seconds for the object to hit the ground. And then part B asks us calculate the horizontal distance that the object travels before it hits the ground. So to find the horizontal distance, we're going to have to be using the velocity in the x direction, the horizontal direction. And we know that to be 50 sine, or just v, we can write this as vi cosine of theta, which is 37. And we also have all that given to us, so vi is 50 and cosine is 0.60. So vi in the horizontal direction is, sorry, not 0.60, it's going to be 0.80, cosine of 37. So vi in the horizontal direction is going to be 40 meters per second. And we also know that there's no acceleration in the horizontal direction because there's no forces acting on it in the horizontal plane. So vi is always going to be a constant 40 meters per second. And again, we can use this equation. Displacement, this time in the horizontal x direction, displacement x equals 1/2 acceleration xt squared plus v initial xt. And we already know that we're looking for displacement. So everything else we know already. Acceleration in the x direction is 0. T is 7. This we can cross that out because that's 0. Plus v initial x is, as we found earlier here, to be 40. And then t again is 7, which we found again in part A, which is the time that it took for the object to land on C. So, which is also the distance we want to find it at. So dx is going to be 40 times 7. which is going to be 280 meters, is the displacement in the horizontal direction of the object. And then part C asks us to find the velocity at 3 different points, which is A, B, and C. So for point A, we know that at the top here, what we know is that for all of these speeds, Vix is going to stay constant because again, there's no acceleration in the horizontal direction. And then so we're basically just trying to find VIY. So we know here at point A that VIY is 0. Why? Because the object changes its direction from going up to going down. So when the object changes its velocity, then we know that it has to hit 0 at that point. So we also use this equation. V is equal to the square root of Vx squared plus Vy squared. So the total velocity is equal to the square root of the velocity in the horizontal direction squared times plus the velocity in the vertical direction squared. So for point A, we know that VA square root. So we know that Vx is going to be constant for all the problems, so that's going to be 40 squared. And then Vy, A we established earlier to be 0 because it's changing directions squared. So if we plug that into a calculator, we'll get that VA equals 40 meters per second. And then for point B, we see that the object is here at the end of this like equal from where the beginning is. Well, we can calculate Vy there using the displacement formula again. So 1/2 AYT plus VIYT. So we use the displacement in the y direction formula to find t, so that we can use that and acceleration to find VBY. So from here to here, the vertical displacement is actually 0. So 0 equals 1/2. Acceleration in the vertical direction is -10 because of gravity. T squared plus VIY we established up already here to be up here to be 30 meters per second. So we plug that into a calculator, we'll get that T equals, using quadratics, we'll get that T equals 6 seconds. So that's the time it takes for the object to get from here to here. And if we plug that into our other equation, that V final equals V initial plus AT, where V final would be VBY and V initial would be VIY, which is, we'll just write the in now, which is 30 meters per second plus acceleration we know to be -10 because of gravity, and the time is 6. So VBY equals 30 minus 60 -30. And if we plug that into the square root equation here, VB equals the square root of VBX squared plus VBY squared. Again, we know that VBX is 40 because the velocity in the horizontal direction stays constant. And we plug in VBY, which we just found to be -30, square that, we'll get that VB equals VB equals 40 squared plus -30 squared, which is going to give us 50 meters per second. Oh, and again, the question actually asks for the speed. So speed is just the absolute value of velocity. So if we want to correct that up here, we'll absolute value it, which is, it still comes out to the same thing. VA equals 40 meters per second. And here, it's not a negative, so even if we absolute value it, comes out to the same thing. VB equals 50 meters per second. And then it also asks us to find it at point C. So we'll just do those calculations again for point C. And again, we know that VCX is 40 meters per second because velocity in the x direction doesn't change at any point. And then we're looking for VCY, which we can find using the VCY is going to equal V initial using this equation. V initial plus AT. V initial Y. So VCY equals V initial Y, we know, found it over here to be 30 meters per second, plus A is negative 10 is of gravity, and T we also found already is to be 7 seconds at point C is the time it took for our object to reach point C. So we have all that. We know VCY to be 30 minus 70 is negative 40 meters per second. It will be plugged into the square root equation for VC. We have VCX is 40, square root plus VCY is negative 40, square root, we get VC equals square root of 40 squared plus negative 40 squared equals 56.569 meters per second. Get the absolute value of that, then we get speed. C equals 56.569 meters per second. So that is it for Q1.